Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all. Yesterday we stopped at this slide. So first, before proceed to the frame design, okay, the tall building design, ada tall building, okay, high rise building ke, medium rise building ke, ataupun low rise building, you need to calculate the wind pressure. Okay, the wind pressure, because for the armrest frame, okay, the combination of wind need to be considered is the wind pressure, the wind load, okay, and also the vertical load. So there are several methods. There are three methods to calculate the wind pressure. The first one is using the simplified method. So this simplified method is for the building less than 15 meter, the height, the H, using the analytical method, while the building with height less than 200 and the roof span is less than 100 meter. Okay, and also for the complex building using the wind tunnel method. So for this syllabus, for our syllabus, kita akan fokus on the analytical method. Okay, panggil procedure boleh, method pun boleh. Okay, kita proceed one by one. So first we look at the simplified method, next analytical method, and also wind tunnel method. Okay, so this is the simplified method. Again, this method is to determine the wind pressure. Okay, wind pressure. So, and again, this is for armrest frame. Okay. So, the wind analysis using the simplified method, okay, is referred to the Malaysia Standard 1553 2002. Okay, so this is the Malaysia Standard Code of Practice on wind loading for building structure. Okay, so kita akan lihat each pages, not each pages lah, pages related with the analytical method, analytical procedure. And this is the equation. Okay, so this equation, the wind pressure is equal to 0.613 multiplied with the basic wind speed, multiplied with the terrain height multiplier, and multiplied with the CPE is the external pressure coefficient, minus CPI is the internal pressure coefficient. Okay, so this is external, this is internal, E and I. Okay, P stands for pressure. Boleh ya? So C, both C is coefficient. And this equation in Malaysia Standard is referred to page 66. Okay, dia adalah appendix, adalah appendix. Appendix A, this appendix is in page 66. Okay, so this is appendix A. Okay, appendix A, and this is the equation to calculate the wind pressure. Okay, so there are two equations. This is for cladding. Okay, the wind pressure equation for cladding and the wind pressure equation for structural system. Okay, and using the using the simplified method, we refer to the structural system. And Vs is this value depends on the zone 1 or zone 2 respectively. So we need to refer to figure A1. Okay, and the MZ cat here is the terrain height multiplier. Okay, terrain is the muka bumi, rupa bentuk muka bumi. As given in table A1, nanti kita lihat. And CPE is the external pressure coefficient. Okay, refer to A23 and also A2.4. Okay, the internal pressure coefficient so shall be taken as 0.6 positive or 0.3 negative. Okay, and KL is the local pressure factor in table A7 and figure A2. Okay, so the basic wind speed refer to figure 3.1. So this figure 3.1 in Malaysia Standard is at page 19. So this is section 3. Section 3, wind speed. Wind speed is where you can find table 3.1. So table 3.1, it depends on the station and the V20, V50 and V100. Okay, and the definition for the 20, 50, 100 is the wind speed for a return period of 100 years, 50 years and also 20 years for V20, and depends on the station and select the value. Okay, this is table 3.1 in page 29 here. Okay, page 29 here. I'm referring to this box, okay, when I mention pages. And meanwhile, for the terrain high multiplier is referred to table A1. Table A1 is at page 67, Malaysian Standard. Okay, so this is table A1. Okay, this is for the terrain high multiplier. Okay, this is terrain height multiplier, and this table only for simplified method. Okay, only for simplified method. Okay, for the analytical procedure method dia ada juga nilai MZ-cat ni, tapi dia MZ kategori tu. Okay, tapi dia refer pada table lain. Okay, so and for this A1, use only for the simplified method and depends on the height of the building. Okay, up to 15 meter. Okay, the height of building is up to 15 meter. I stated earlier that for the simplified method, the total building height is less than 15 meter or equal to 15 meter. Okay, so this is terrain category 1, category 2, 3 and 4, and this is the description for each category. Okay, later you can read this. And next is the external pressure coefficient, refer to A2.3 and A2.4. So this two coefficient is at page 69. Okay, page 69 in Malaysia Standard. Okay, so this is A2.3, table A2. So this is for external pressure coefficient, CPE for leeward wall. So this is for leeward wall, and 2.4. Okay, 2.4 is the. Okay, so this is for leeward wall. Okay, so this is for the side wall. Okay, and for table A4, under the appendix A.2, the external pressure CPE for roof. So this is for roof. Okay, for roof, the external pressure. And the selection depends on the horizontal distance from the windward edge. For this one is for the side wall, and this one depends on the alpha. Okay, so the alpha D over B, and then we select the CPE. Okay, the CPE. So D over B here. Okay, so the D here is the, if you still remember, as example 2.1, we have the layout plan. The layout plan is like this. Okay, if you still remember, so here is 18, and here is if not mistaken 51. Okay, so here is D, the short H is B. Okay, so this is the DB. Okay, next is the CPI, the internal pressure coefficient for surface of enclosed building, which shall be taken as 0.6 positive or 0.3 negative. Okay, so the two cases shall be considered to determine the critical load requirements for the appropriate condition. Okay, so this is the figure 3.1 and table 3.1 extracted from the Malaysia Standard. Okay, so this one is the Peninsular Malaysia map. Okay, as you can see here, this one is the zone 2 here. And here is the zone 1. Okay, alright. So zone 2, okay, zone 2, the VS here, so the basic wind speed depends on the zone. For zone 1 is 33.5 and zone 2 is 32.5. Okay, and this is wind speed for various return period, 20 years, 50 years and 100 years. Okay, depends on the location, the station. Okay, so this is table 3.1 and this is the table A1 for the terrain height multiplier. Okay, terrain height multiplier MZ cat ni kategori lah. So you have seen this in the Malaysia standard. Okay, based on it, category 1, 2, 3 and 4. And this is the CPE, the external pressure coefficient. Okay, and this is the alpha. Alpha dekat area roof lah. Nanti saya tunjuk macam mana nak baca alpha. Bukan nak definition of the alpha here. Okay, so this is the slope, the roof slope. The roof slope. Okay, yang ini kalau roof kan, dia ada alpha, dia nak alpha dia. Okay, boleh ya. So how the degree, in degree. Okay, you need the degree. Okay, and here is the internal pressure coefficient A24. Okay, for the slope less than 10 degree. Okay, for the and R for the gable roof. So this is for roof. Okay, so this is flow slope more than 10 degree. Okay, boleh ya. So this is the CPE. Okay, so meanwhile for the A6 here is for the similar with this table A4, but the R for hip roof, for the hip roof, this is for the gable roof. Okay, dalam Malaysia standard pun ada tunjuk ya. Nanti kalau kita jumpa gambar rajah tu saya ingatkan saya lah. Okay, kita dekat alpha. Okay, so next is the analytical procedure, so ataupun analytical method. Okay, this is the second method to calculate the wind pressure. Okay, wind pressure. Okay, so the wind analysis using the analytical procedure. Okay, this is the pressure. Okay, the wind pressure equal to 0.1613 multiply with the design wind speed multiply with the this is the aerodynamic shape factor, and here is the what we call it as the dynamic. Sini dynamic ni kita panggil apa ya? Ini adalah kita namakan sebagai dynamic response ya, dan dynamic response. So CDYN ini adalah dynamic response, C dynamic, saya panggil C dynamic. So CFIG ini adalah aerodynamic shape factor, saya panggil C fit lah, senang. Okay, alright. And to get the to complete this equation, you need first to determine the V, the design wind speed. Okay, the design wind speed is the V seat. V seat is the site. Okay, L is the important factor. V seat is the side wind speed. Okay, side wind speed ni tak ada L sini tak ada L, silap sini. Okay, ni tak ada L. Okay, so the V seat here is the side wind speed. L is the important factor. Okay, V seat ini saya panggil V seat lah ya. Okay, dia V side sebenarnya. Yes, V stands for the wind speed. Okay, so the V seat is VS multiply with the wind directional multiplier, multiply with the terrain height multiplier, multiply with the shielding multiplier, multiply with the MH. Okay, MH here is known as apa ya? Hill shape multiplier. Okay, MH is the hill shape multiplier. Okay, boleh ya. Okay, meanwhile for the basic wind speed ini as shown in figure 3.1 yang tadi. So for the zone 1 is 33.5. Okay, it depends on the area, and zone 2 is 32.5. Ini bukan negatif, ini sama dengan 32.5. So directly use this number. Okay, alright. Kalau nak lagi tepat, you pergi kepada table 3.1 lah. Okay, alright. So the meanwhile for the wind directional multiplier is equal to 1. The MZ cat. Okay, this is table 4.1. table 4.1. Okay, compared to the simplified method dia guna table, saya lupa tadi MZ tu adalah dekat table A1. Kalau tak silap saya, table A1. So, this is table 4.1. So, table 4.1 here, okay, kita dapat refer dia pada muka surat at page 33. Okay, 33 in Malaysia Standard. Okay, so this is the Terran height multiplier for the analytical procedure, analytical method. Okay, untuk the simplified method dia lain. Sekejap ya. Okay, so for the analytical method, okay, procedure, the Terran height multiplier is referred to table 4.1. Okay, meanwhile for the simplified method, the Terran height multiplier MZ cat 2 category 2, it refer to the, if not mistaken, is table A1. Okay, table A1, okay, dalam appendix A. And this selection is based on the category. Okay, this is the category and the height of the building. Okay, so height of the building. So this is Z. Okay, dia ada, so kita ada term Z equal to H. Okay, equal to H. Alright, equal to H. So this is for the windward. This is for the leeward. Okay, kalau leeward di H dia constant. Total H. Okay, constant total H. Meanwhile, for the leeward, it depends on the height for each level, each story. Okay, boleh ya? And the category is mentioned here. The description for the category, this is category 1, 2, 3, and 4. Okay, so you can read this one later. Meanwhile, for the importance factor is referred to table 3.2 in Malaysia Standard, and you can refer it at page 31. Okay, so in page 31 here, kat sini kan, the importance factor. Okay, so depends on the category of structure. Category, this is the category. Okay, category yang ini. Oh, sorry, itu lain lah yang ni ya. So yang kategori ni adalah description dia. So yang ini adalah the first one. The category number 1 is building. This is for the importance factor ya. Buildings and structure that represent low hazard to human life, such as agricultural facilities, temporary facilities, and minor storage facilities. Okay, so the design is maybe 10 years lah, less than 10 years. Okay, so this is all building and structure except those listed in category. Yang ini, for the second row ini, any structure which is not in category 1, 3, and 4. Okay, so the second one is building and structure where the primary occupancy is one in which more than 300 people. Of course lah, kalau 5 story kan, let's say 10 story kan, for sure it is more than 200 people lah, congregate in one area kan. So this is the third category is the essential building and structure, hospital. This is the example for the nature of occupancy for the category structure number 4. Okay, boleh ya? Alright. And this one is category 1, the same category actually, but this one description is based on the Terran height multiplier. Depends on the bentuk muka bumi. Okay. Meanwhile, for the shielding multiplier, MS the shielding multiplier, refer to table 4.3. In Malaysia Standard, you can find this table in page 35. Okay, so this is shielding multiplier MS. So shielding multiplier MS appropriate to a particular direction shall be given in this table 4.3, where the effect of shielding are ignored or are not applicable for a particular wind direction, or where the average upslope ground gradient is greater than 0.2, MS shall be equal to 1. Okay, di mana ada shielding effect tu kita ignore, ataupun no information, kita ambil je equal to 1. Okay, boleh ya? So this is table 4.3. Okay, so the shielding parameter here is the S here, S the shielding parameter, so M is the multiplier lah, so MS. Okay, so Okay, so this is the external pressure coefficient CPE for rectangular enclosed building. So this is table 5.2a. Okay, 5.2a is for the windward wall, and for 5.2b is the leeward wall. If you still remember, what is the windward and also what is the leeward? Okay, wall. Okay, so this is the building. So this is the building, and the wind comes from this direction. Okay, thus here is the windward wall, and here is the leeward wall. Saya susah nak tiba-tiba dia ni. Saya susah nak tulis leeward wall. Okay, leeward wall here. Okay, so kat sini adalah negative pressure. So ini ada dia ada uniform pressure kat sini. So kat sini dia ununiform pressure. Okay, so that is for the external pressure coefficient. So external pressure coefficient from table 5.2a and table 5.2b. So again, the aerodynamic shape factor for the external pressure is the external pressure coefficient multiplied with the Ka, Kc, K1 and Kp, and basically all these value for the Ka, Kc, K1 and Kp is equal to 1 unless stated otherwise, and we can refer this value in appendix C. For Ka, Kc, K1 and Kp appendix C, and appendix C in Malaysia standard is at page 49. Okay, so this is 5.4.2 area reduction for Ka. Ka is the area reduction factor. Okay, for roof and the side walls. Okay, table 5.4 is the area reduction factor. Okay, so we take the Ka value depends on the tributary areas. Okay, the tributary areas. Okay, and basically we took it as 1, which is less than 10. And this one is the Kc combination factor 5.4.3. Okay, table 5.5 is for the combination factor Kc. Okay, so Kc kita ada kat sini several design case. So this is where wind action from any single surface contribute 75% or more than to an action effect. Okay, so this is the example of the diagram. Okay, due to the combination action. Okay, and this is the example diagram for this design case number 3, number 4. Okay, so and this is for the all other cases, and basically we take it as 1. Okay, unless it's stated the design case here. Okay, and next is the local pressure factor K1 for cladding. Okay, we need to consider also the cladding. Okay, in the wind pressure also. Okay, so the local pressure K1 shall be taken as 1 in all cases except when determining the wind forces applied to cladding, the fixing and the member which directly support the cladding, and the immediate facings of this member. Okay, so for these cases other than 1, the K1 shall either be taken from table 5.6. Okay, for the area allocation indicated, or be taken as 1. Whichever gives the most adverse effect when combined with the external and internal pressure. So this is table 5.6. Okay, so this is table 5.6. Okay, this is the windward wall. Okay, side wall. Okay, for the roof. Okay, so this is all other radius. So this is dia lebih detail lah roof. Okay, dia punya windwall, dia punya side wall dan sebagainya. Okay, and this is the dynamic response factor. So dynamic response factor shall be taken as 1 unless the structure is wind sensitive. Okay, unless the structure is wind sensitive. Okay, so refer to section 6. Okay, section 6 sekejap ya. Okay, so before we go to the dynamic, okay, the C dynamic. Okay, so this is the Kp, the porous cladding reduction factor, based on table 5.8. The porous cladding shall be taken as 1, except that where an external surface consists of permeable cladding. Permeable cladding maksudnya kat sini adalah apa ni, surface allows material macam liquid ke kan, gases ke, dalam kes kita air kan, air tu gas lah, gases kan, air, sama ada carbon dioksida ke apa, dalam air kan ada banyak jenis ni chemical to pass through either in or out, kita dia in lah. Okay, so that is permeable definition. Okay, alright, then let's go to the section 6. Okay, this is section 6 for the dynamic response factor, page 55. Okay, so C, D, Y, N in this dynamic response factor shall be determined for structure or elements of structure with natural first mode fundamental frequency as follows. Okay, dia ada perkataan natural first mode fundamental frequency kan. Ini semua adalah dynamic language. Okay, dynamic dan kita panggil apa ya? Dynamic ada perkataan lah, okay, under the dynamic topic language. So basically we take it as 1 greater than 1 Hz. The dynamic response factor is equal to 1. So this is for the less than 1 Hz. This is for the cantilever, for the tall building and towers. Okay, boleh ya. So this is the definition for the H here. Okay, so the C dynamic also can be calculated using this one. Okay, alright. Oh sorry, you need to calculate this one. Greater than 1 Hz, less than 1 Hz. Okay, alright, so you need to calculate the dynamic response factor using the equation 10 here. Okay, while the S here is the this is the S here, the size reduction factor that give BOH is the given that given BOH here is the average breadth of the structure between height 0 and also H, B0H, BOH, and the value of S is given as follows. So this is the definition for S. Definition for S here is as stated in equation 12, this S, and ET here is the spectrum of turbulence in the approaching wind stream given by equation 13. Okay, so to complete this equation, you need to calculate this one. Okay, and NA is basically usually is given. Okay, and this is the building design wind speed lah. So need to refer to clause section 2. Okay, and H here, H kat sini ya, H kat sini, this H and this S ya, SH. Okay. S is the height of the level at which action effect. H is the average roof height. Okay, kalau ketinggian bangunan tu 25 mm lah, so itu adalah H. Okay, and the LH here is the turbulence intensity obtained from the table 6.1 by setting Z equal to H. Okay, Z, nanti saya terangkan, Z equal to H. Okay, and the GV here is the peak factor for the upwind velocity fluctuation. Okay, so no need to worry about GV. We take it as 3.7. Yeah, and the BS here is the background factor. Okay, and here is the BS, where the value for the LH here, the LH is 1000 H divided by 10. Okay. Alright, and here is the BSH. BSH is the average breadth of the structure between the height S and H. Nanti kita lihat ya, contoh. Okay, BSH. So that is for the dynamic response factor. Okay, refer to section 6. Okay, next is the wind tunnel procedure. So this is the wind tunnel procedure. For the wind tunnel ni untuk yang complicated lah, complicated design. Okay, so this wind tunnel procedure basically used to predict the wind loads and responses of a structure, structure component, cladding, okay, to a variety of the wind condition. So this is example of the wind tunnel. This is the, you nampak kan, at both side ni dia ada macam wall kan. So this is the tunnel. Okay, tunnel, and then dia bina, kita panggil apa ni, replika kat sini, and each location dia ada dia punya sensor then the wind dia akan pass through this tunnel dalam nilai yang berbeza, dan dia akan analyze until dia failure. So how much what is the maximum wind it can stand. Okay, so all this apa ni, the structure around this. For example here, if you can see, this is one town. Okay, so they design more complicated analysis lah. Okay, using this wind tunnel. So under the wind tunnel topic, there are others method, small method under wind tunnel. Wind tunnel is the big topic. Okay, ada kaedah ni for the wind tunnel, kaedah B for this wind tunnel, kaedah C dan sebagainya for the wind tunnel. Okay, tapi kita belajar yang basic saja. Okay. So this is the tunnel. So for them to analyze, okay, the responses of the structure. Okay, structure component, column, beam, okay, roof dan sebagainya, kan. Okay, dia punya sway, dia punya deflection dan sebagainya, dan cladding dia dan sebagainya. Dan dia tak bina macam tu saja, dia ada dia punya sensor dia lah nak ambil bacaan data. Okay, so ini adalah connection with the software lah, of course lah. Okay, connection with the software, you can see here. So this around here is the this is the negative kan, dia nampak pressure suction, dia macam suction kat situ kan, suction. So wind comes from this side. Okay, this is the what we call it as the windward. Okay, and here is the leeward. Okay, so dia pas here, you nampak kan bentuk dia kan. So here is the negative pressure, suction pressure here. Okay, dia adalah dia punya sensor TV dia punya cara dia nak dapatkan data itu, ya. So this is another type of the wind tunnel procedure, not type. Okay, example of the wind tunnel procedure. Okay, nampak kan? Ni dia ada black color here, dia ada function dia, ya, as its own function. Okay, to read the blowing dan sebagainya. Okay, ini pun ada function dia setiap yang macam kecil ni kan. Okay, so this is one example for the Menara Taming Sari. Okay, before constructed, this Menara Taming Sari punya kita panggil apa ni, model. It tested in the wind tunnel techniques, okay, wind tunnel method, okay, to check the response of the structure lah, okay, dia punya structure response due to the wind load. Okay, so wind load dia akan berbeza lah, okay, dia akan tinggi, so sampai mana, setakat mana maksimum dia akan can stand, okay. Okay, so this is the example, okay, for the pressure from the wind tunnel analysis, okay, wind tunnel method. Okay, you can see here, this is the red color. Basically the red color is the maximum, shows the maximum stress lah. Okay, so the blue color is the less stress. Okay, less stress. Selalunya begitu. Okay, unless, tapi this color you boleh control. Okay, dia boleh control you nak color apa for the stress color. Selalunya merah is for the more stress compared to the blue color. Okay, so kat sini kalau if the wind load is increasing, so this area is expected to fail first. Okay, and also it depends on the direction of the wind. Okay, when this wind tunnel method is carried out. Okay, so and this is, we can see the computational fluid dynamic, okay, from the wind tunnel method, wind tunnel analysis, wind tunnel procedure. Okay, kita nampak kan dia punya ni, tapi this is not my ni bukan bidang saya lah. Okay, so saya nak cerita panjang sangat pun tak berapa pandai lah, ya. Okay, tapi basicnya begitu. Okay, sebab saya bidang konkret, so this is motor structure. Okay. Okay, so this is example 2.2. Okay, example 2.2.